Hello, everyone. What I want to do is go over collected homework 5. So the scores were fairly typical so far for the course, about a C, average, median, C minus. So yeah, let's go over this. So we have an annuity in perpetuity. So someone asked me, well, when does that end? Well, the point is perpetuity means it keeps going and going and going. Pays 100 at the beginning of the first year, third year, et cetera, and 200 at the beginning of the second year, fourth year, et cetera. Interest is 4%. So draw a time diagram. So remember the first year is 0 to 1, the second year is 1 to 2, et cetera, et cetera. So it has no ending, so it doesn't really make sense to that. So the beginning of the first year is 100. Beginning of the second year, 200, and et cetera, et cetera. I wasn't too harsh if you screwed that up, but yeah, you really should get used to what the beginning of the first year, beginning of any year means. You know, the nth year is t equals n minus 1 to t. Sorry, t equals n minus 1 to t equals n. That's the nth year. Okay, so let's get the 2-year interest rate. Call it J. This. All right, well, to get 2 years of growth, you just compound 4% growth twice. So you square 1.04, subtract 1.0816. Okay, so that's 2-year interest rate. So just like before in the homework, or in the lecture rather, and the quiz problem, we break this up into 2 annuities. Let's do the 100 first. It's a little easier. Not that the 200 is particularly hard. Right, so 0, 2, 4. So periods are every 2 years. Payments of 100 at the beginning of each period. Per period interest rate, 2-year interest rate is 0.0816, 8.16%. So the present value formula is going to be 100. 1 plus your interest rate, 1.0816, over your interest rate. And that is 1,325.49. And I'm going to add this to the other present value. So I'm not going to do any manipulations with this. So I don't need to round any further than a round to the nearest penny. All right, so the next one, remember, is a little tricky. So 1, 3, et cetera. You do 5, doesn't matter really. That's 200, 100, et cetera. So the present value, we're going to take the present value at t equals 1. That's treating this, taking the present value t equals 1 at the end of the first year. It's annuity due. Same thing, payments are at the beginning of each year. And so it's 1 plus your interest rate, your 2-year interest rate, 1.0816 over 0.0816, whatever that is. I'm going to discount that by 1 year, and I don't have room to write it here. 0 here. So I take this thing, (200) 1.0816 over 0.0816 times 1 over 1.04. I'm discounting it by 1 year, and the 1 year interest rate is 4%. So this is going to be 2,549 and 2 cents. That's the present value at t equals 0. So add these two up and you get the total present value. The present value of my original annuity. Yeah, so 1,325.49 plus 2,549. And some people got slightly off answers just because I think they rounded more than I did. It's fine. So 3,874.51. Okay, so number 2. So some people did it like I did it in the video, even though I didn't make a comment that the way I do it in the video is not, I mean, it's not the easiest way to do it. I was expecting more people to do this like I did almost the same problem on the quiz problem from 2021, which it's on that video. So I'm going to do it that way, just a little quicker. Okay. So I have 2 annuities, both annuity dues, common present value of 2,000, and a common effective annual interest rate of I. The first makes 1,000 at the beginning of every 2 years. So let's just focus on that. So what's a little easier, and really, it's when I say a little, it's a little. It's not much harder, especially if you're a math major. It doesn't make things that much easier. So let's say J1 is the 2-year interest rate. Okay. So yeah, you don't really need to draw a time diagram because we're saying 2,000 is the present value of an annuity due. It's 2 annuity dues that makes payments of 100 at the beginning of every 2 years. So we have an annuity due, payments of 100 at the beginning of every 2 years. So J1 is a 2-year interest rate. So it's 1 plus J1 over J1. So divide by 20, divide by 100, multiply by J1. You get 20. J1 is 1 plus J1. So solve for J1. 1 over 19, which is 0.05263. Now, what a lot of people did is they took this, or they really took 1 over 20. They did the annuity immediate formula. Not a huge deal. So what a lot of people did was they compounded this 4 times. Well, that if you do that, raise this, add 1 and raise it to the 4th, you're going to get the 8-year growth factor. I want the 6-month growth factor and 6-month interest rate. Second makes payments of X. Let me get rid of this. Sorry, the eraser is definitely awkward. Paint's eraser is much better. All right, so let's now focus on the second one. So the second one makes payments every 6 months, at the end of every 6 months. So let's first get the 6-month interest rate. And by 6-month interest rate, I mean the equivalent effective annual interest rate. Sorry, the equivalent effective 6-month interest rate corresponding to the 2-year interest rate of the effective 2-year interest rate of 0.05263. Okay, so just like I did in that video, the way I like to do these is instead of plugging into a formula, which I absolutely hate, so if I compound 6 years worth of growth 4 times, I'm going to get 24 months, which is 2 years. And I know 2 years of growth is just 1 plus your 2-year interest rate. So that means J2 is going to be 1.05263 to the 1/4 minus 1. And we have this interest rate of 0.0129. Okay. All right, so we're given that, and again, you don't really need a time diagram. Just this is now it's plug and chug. We have an annuity. So I guess I was a little ambiguous here when I say 2 annuity dues, and the second one makes payments of X at the end of every 6 months. Anyway. So yeah, it's payments at the end of every 6 months. So use the annuity immediate formula. Present value of 2,000 is the X payments over my per period interest rate of 0.01291. So X is 2582. Yeah, if certainly if I have a little something like that, I'd be sure to let me know if something doesn't quite make sense 100%. Just a little typo. It's easy for typos to slip through. All right, so I have a 20-year loan of 12,000. We paid with annual payments of $750 at the beginning of each year. So I think for the first day or two that I had this up, I had 15-year loan, and then I changed it. I think only like 1 or 2 people had 15-year. And if you had 15-year and you got a negative interest rate for an answer, you did it right, then I gave you full credit. I just don't like having negative interest rates because it just looks a little weird since most interest rates are positive in this course. But anyway. All right, so for this one, you need the calculator. And actually, speaking of which, let me bust my calculator out via the emulator. So just give me a second. Let me. Right. Oops, sorry about that. All right, so yeah, I have an interest rate change at t equals 5. So I'll just draw the time diagram here. One, 2, 5, 6. Right, so everything is 750, and it's the beginning of each year, so we're dealing with annuity dues. Okay, so here for the first 5 years, interest is 3%. And here we don't know. All right, but we still, as we always did, break this up into 2 annuities. So I'll put a 4 here. So we first look at the first 5 payments, 0, 1, 2, 3, 4. That's 5 payments. And the payment periods end at t equals 5. So I have an annuity due. Right, so this is just simply 750A double dots. That's the annuity due, 5.03, and well, let's see what that is. So first, I'm going to clear TBM, and then I want to go into annuity due mode. You have VGN here. Right, so let's start entering stuff. 750 payment, 5N, 3 interest, compute, present value, 3573-82380. Now, of course, I probably would store this somewhere. Let's say store it in the first slot, or maybe make it a positive and then store it in the first slot. Let's just check it's there. Yeah, so it's there. So yeah, for this course and other finance courses where you might need a calculator, it doesn't have to be this one, but whatever calculator you utilize, do get used to and use the memory keys. They're just so nice and so convenient, and yeah, it's invaluable passing exam FM. Okay, so next we're going to take yeah, let's take from 5 onward. So the last payment here is 19. So we have 15 payment periods. Okay. So present value as an annuity due is going to be at t equals 5 because that's when the first payment is. So it's 750 A double dots 15 I. Well, I have to discount it by 5 years. I want present value t equals 0. So it's going to be 750 A double dot 15 I times interest is 3%, so 1 over 1.03 to the 5. Right. Now we just do that in the calculator. 750 times 1.03 to the minus 5. 646,95659 roughly. Yeah, that was kind of hidden. So all I did was 750 times 1.03. And I like to do negative exponents on the calculator a lot of times rather than doing like 1 over something, because it's just, you don't need parentheses. So, all right, so let's just write down what this says. So total present value was given to be 12,000. So the first present value of the first 5 payments was 3537 8230 plus 6469 5659. A15I. So solve for A15I. 13.07998. Okay. And very few, not too many people seem to be able to solve for I. I don't know why, because I had an entire video on that. If you're watching the videos, you should be able to get it. And I just want to warn people who maybe aren't watching the videos or whatever, that I am not going to curve, and there's no extra credit. So the grade you get is the grade you get. All right, so I'm still in begin mode, which is good. Second. That. Okay. Yeah, so let me clear the TVM. Cleared. All right, so again, to not make your calculator angry, we have two options. We can either make a payment of one. So implicitly, there's a 1 here. If you want, alternatively, keep this 646 here. It doesn't matter. So make the 1 negative or make the 13.07998 negative. Again, the logic is that so this is saying that the present value of 15 payments of 1 at some interest rate is 13.07998. So to get these payments of 1, we can take the perspective of I have to pay $13.08, or for the loan company to get $13.08, they have to shell out $1 every beginning of every year for 15 years. Okay. Either way, someone's got to pay to get something. So I'll make the present value negative. This is my present value, 15 N1 payment, compute interest, and we get 2.03088. Now, if you really want to, you can basically write this out and then use an online grapher to get the answer, which is a lot of work. I don't think I did that in a video. I guess I do, but we'll just use a calculator. You really don't want to. I think I gave you, if you did everything right but didn't get your interest rate, I think I gave you 7 out of 10. So I only took 3 off. All right, last but not least, typical rent type problem. So this was shouldn't have had last year. I should have said first year, but otherwise it was pretty clear. So second year was 8%, 4% more than 1,000. Third year is 4% more than 1040, et cetera, et cetera. No one got confused by that here. Yeah, it pays 1,000 per month at the end, 1,000 at the end of each month for the first year, and then keeps going. So yeah, it's at the end of each month, not beginning. So. All right, so yeah, let's get the accumulated value in the first year. 0, 1, 2, et cetera. So nothing special here. All right, so I-12 is 6%. You really can't forget or you have to be mindful at least of what that means. So if J is a monthly interest rate, then this is nominal interest compounded monthly. So it's 0.06 over 12 is 0.005. It also does not mean the equivalent effective annual interest rate is 6%. We'll figure that out in a second. All right, so don't really need the time diagram, but whatever. Draw it. So accumulated value is just 1000 S12. It's not double dot, it's 1000 at the end of each month. 0.005. And this is 12, 335, 56. Yeah, 56237. Okay, so get out of annuity due mode, and we're in annuity immediate mode. Clear TVM. 1000 payment 12 n times 100 for the interest. 0.5% interest. Compute future value. 12, 335, 56237. And remember, I called that P to make life easier. So we have, so this is months. So now we have in years, 20 years. So at the end of the first year, we have P. At the end of the second year, everything's the same, except instead of 1000 per month, it's 1.04 times 1000. So just multiply everything by 1.04. Keep going, et cetera, et cetera. So right, so the pattern would be it's 1.04 to the n minus 1 times P. So this is 1.04 to 18, 1.04 to 19. All right, so sorry, this is 30, so it would be 29, 30. That. So this would be 28, 29. All right, so remember for this kind of annuity, so first of all, sorry, we have to get the equivalent effective annual interest rate. Remember the formula, it's 1 plus I12 over 12. I12 is 0.06. To the 12th minus 1, that's 0.06168. Okay. So the accumulated value is P 1.06168 to 30. Just plug and chug. We have increases of 4% each year. So 1.1 plus R to 30. I is, or in the formula is generally J, is 0.06168. R is 0.04. That's 0.06168 minus 0.04. Remembering that P is just that. Remember, this is what P is. So dumping everything into a calculator, get this nice big number. 1581, 518, 15. All right, hopefully this helped. And yeah, I will have the exam up by tomorrow at noon. And remember, that is due Sunday night, and I will have homework 6 graded, and a video up on Saturday, by Saturday night. All right, good luck. Sorry, it's 5/1/8/15. I have a 1 here. Yeah, good luck on the exam, and yeah, only 2 more weeks, so we're actually, believe it or not, almost over. Just absolutely flies. But, all right, yeah, so long. Take care. Bye bye.